Here's the material that we start dealing with. We're going to be talking about a new caliber or a new type of set of equations called systems. This entire chapter, this entire unit that we deal with, is built around our ability to work with systems. Quite simply, a system of equations is two or more equations that involve two or more unknowns. Most of our systems are going to be relatively simple systems. They're going to look like this. Two equations, two ways to describe a relationship between x and y, and only two variables. If we can get a good understanding of how simple systems work, then we could expand that to more complex systems if you ever needed it somewhere. So we don't know where you're headed with this course, so we're trying to cover all bases. So this is what we call a 2x2 system, two equations that have two variables. And they are going to ask us to be able to spend a lot of time solving systems. But before we start into solving systems, we want to give you the mechanisms or the means to be able to figure out whether a solution to a system is correct or not. Because we have more work involved in these problems, more pieces of the problem by hand, it's easy for us to make a mistake. And I know that we're getting pretty used to doing the problems the right way to begin with on the homework stuff, but some of us are still relying upon, well, if I miss it the first time, I get a second chance, and then I get a third chance, and we don't necessarily take ownership as soon as we should about being correct with the problem the first time, and we waste time, not waste time, but we take valuable time that could be devoted to other things by having to rework a problem because we were careless somewhere along the line. So we start off with showing you how you can check a potential solution to a system, something that should be part of everything that we do by hand in a problem. So if this is a solution to the system, and they want to know, is it a solution, then that means that the x and the y values in both equations will keep these numeric values, and they will both generate true statements. Checking by hand is just by hand arithmetic. Checking with the calculator, notice that most of our systems are set up where the x and y work is on the left-hand side of the problem, and it works together toward a constant value, so we could drop this into a calculator pretty easily. If I were solving this problem by hand, if I was trying to check it by hand, then I would be saying, I would be looking at this statement. Is 2 times the value of x that they gave me plus the y value that they gave me actually equal to 8? That's what mine's saying when I'm checking a statement. And you can see that if I did it by hand, some of the problems are not very difficult. You're either going to get a yes or no. There are no maybes out there. So we get a yes answer to this one. So that ordered pair satisfies that equation, but that doesn't mean it automatically satisfies the second equation. It's kind of like my wife and I when we decide to go see a movie. I say the first thing on the list, yeah, I'd like to see that, but she's not going to be happy. She's not going to be satisfied unless she likes to see it as well. And of course, if my wife's not happy, then I'm probably not happy too. So that's just the way it works in the dynamic out there, okay? So you can't say that just because it satisfied the first equation that it's automatically going to satisfy the second equation. You do know, however, that if it doesn't satisfy the first equation, there's no sense in trying to go on to the next equation because you got a failure on the first shot. So the second part of the problem then would ask us for the second problem, is the second equation 4 times the x value that they gave me minus the y value that they gave me equal to 4? And that's going to be a yes or no answer as well. So unless you're prepared to argue that 16 minus 0 is equal to 4, I think you're going to get a great big fat no out of this particular problem. So this suggestion about this might work did not satisfy both parties at the same time. A system, another way you might see it referred to, they talk about simultaneous at the same time. Simultaneous equations. Whatever happens has to satisfy both of them at the same time. Now the good news about systems, and we're having to solve by hand. I'll give you the good news first. The vast majority of the problems we're going to be doing in the calculator. But because we don't want to make you 100% calculator dependent, we do have to hold you responsible for solving by hand. Our systems are all going to be linear systems, meaning that when we graph them, if we graph them, we're going to get straight lines. We aren't going to have to worry about exponents in the problem. We're not going to have to worry about squaring and factoring or any of that kind of crap. It's just straightforward, simple, first-degree equations. Okay, so because they're lines, there are certain ways that we could approach problems. When you solve systems,